Welcome to this tutorial. In this tutorial we are going to focus on Wireshark. Wireshark is a tool for troubleshooting SIP. So we are going to discuss Wireshark as a tool for troubleshooting SIP with a special focus on MiVoice Business. So firstly, we are going to talk about what is a SIP trunk, what is SIP basically. We are going to discuss what is SIP, and then we are going to look at Wireshark. What is Wireshark, and we are eventually going to demonstrate how to use Wireshark. So if you are interested in these topics, so stick around and let's go through the video together. So we begin by discussing what is SIP. SIP, or a Session Initiation Protocol, is the signaling protocol that controls VoIP communication, which is voice over IP. It handles call setup, management, and termination. So by call setup we mean signaling, which is done by way of sending invites, and SDP, session description protocols, and then management and the termination, which you can call the tear down. While RTP, the real-time protocol, carries the actual audio. So let's think of SIP as a coordinator and RTP as the actual voice packets, which means the voice messenger. Okay, we carry on. Let us look at the SIP call flow. A typical SIP call flow has an invite, as a call initiation. If we need to start a call, we start by sending an invite from the caller. We send an invite to the SIP proxy. The SIP proxy could be your okay, from the SIP proxy to the callee, or what we can call the receiving side, the receiver. So the caller could be an extension calling internally through MiVoice Business to another extension also internally, or it could be an extension going to MiVoice Business and also going to the service provider and going to the receiver, which is in the world outside somewhere there. So we are going to give an invite from the caller to the callee, and then number 2, once the let's use blue. Once the invite Okay, let me try and change color here to blue. Let's change our color to blue. So once the invite is received by the proxy here, the proxy relays the invite upstream. And then secondly, the proxy or our service provider will send a trying and then a ringing, which is responded to by OK and 5 and OK arc. And then RTP audio starts going through, and when they are done with the conversation, a bye is sent from which other side terminates first. Okay, then we move on. Okay, let's dive deeper into the SIP messages. So firstly, an invite is sent to start a call. So let's say this is our caller, this is our let's just say this is our receiving side. So an invite is sent to start a call. And then this is our A is our caller and B is our receiver, the receiving end. So an invite is sent to start the call. So an invite has some SDP options in them. We are going to have a look at that. And the receiver responds to the invite with a 100 message, which means trying. What is it trying to do? To connect. It is trying to process the call. Call is being processed. And when the call has been processed successfully, destination alerting when the receiver is ringing, which means it's playing the bell is ringing. The bell is ringing or is playing a sound. It's going to send a 180, which means ringing, and the caller is going to respond to that with a 200 OK, which means I am accepting the call. I am accepting the call. If the receiver answers, I am ready to take the call. And this one is going to acknowledge, confirm connection, which means answered here. And so once the call has been answered, then RTP kicks in. So we now have RTP packets flowing in both directions, and eventually either side can hang up the call, which means it's going to send a bye, and this one is going to acknowledge the bye with an OK, which is the tear down or call termination. So this is what we are also trying to show here. An invite is sends an invite, then we get a trying, we get a ringing, we get an OK, we get an acknowledgement, we've got RTP streams going directly in both direction, then we've got a bye, and we've got an OK. Okay, then we move further. Now we talk about Wireshark. What is Wireshark? Wireshark is a free and open source packet analyzer that lets us see network communication in real time. It decodes thousands of protocols including SIP and RTP. It's the go-to tool for web engineers because it reveals what's really happening on the wire. So let's move further. So what is it that Wireshark shows us? Wireshark is going to reveal to us number one is going to show us SIP. So because when we run a packet capture, with Wireshark, we are going to get a lot of stuff coming in. So sometimes we might want to filter so that we concentrate on certain packets, and our packets of interest is the SIP packets. So we then need to filter the packets that we have captured so that we remain with the only ones that we want. For example, we can filter SIP, which is going to show us only the SIP signaling, or we can filter by this command sip.csig.method is equal to invite, which is going to show us invite messages only. Or we can say csig method register show registration, or we can filter RTP, which is going to show RTP voice packets only, or we can do a combination of filters just for us to be able to drill down and watch some specific traffic. Okay, so at this point, let us do a demonstration. Let us do a packet capture demonstration. And then we start by downloading and installing Wireshark. And we do this by we open a web browser of our choice, and then we can say Wireshark download. Then we come here, we are going to download Wireshark network analyzing tool. Then we choose which one applies to our device. In my case, I can choose to download this one. Then we start to download. And then we wait for it to complete the download. So when the download is completed, we are going to install Wireshark on our computer. And once we are done installing it, we are going to run the Wireshark. We are going to run the Wireshark. So once we run or open the Wireshark, once we run it or open the Wireshark, we are going to come to here, and it is going to ask us which interface on our PC do we want to capture packets for. Which interface do we want to capture packets for? In my case, I've got this interface, I've got this interface, I've got this interface, I've got so many interfaces, but I am going to end up the one that I want us to use is this one. So I'm going to select that one. I'm going to select the Wi-Fi one. I'm going to select this one by double clicking on it, and already it is capturing some packets. It is capturing a lot of information that is happening on that interface. So it is very important to set up your Wireshark to be able to show you date and time. Date and time is very important, because we are going to change the date and time. Let me just show you how you change the so that it displays date and time. Let's pause there. We go to view, and we go to time display format, and you have to make sure that we go to time and display, time display format, and we make sure that date and time is selected. Why is this important? Because we might want to look into our traces. An event that happened at a particular time or a date after we run our packet capture should be able to say we are looking for an event that occurred at 2140 hours at 43 seconds and so forth. So it is very important for us to be able to see this, the date and time. So in demonstrating, I am going to start the Wireshark, continue without saving. Let's see here. Let me exit this guy. So I am going to run microsip, which is going to register. I am going to open microsip, and it is going to send a registration request to the controller. so that it can register. So we are going to capture the registration process. We are going to packet capture the registration process, and we are going to have a look at it. And our first attempt is going to be successful because everything is set up correctly for the micro SIP to register. Then we are going to put, as a second test, we are going to put wrong credentials on micro SIP and also do the registration again, and then it fails, and then we capture that failure and we look at it to discuss it. So I am going to run micro SIP right now. Micro SIP. So micro SIP, it's saying online here. So which means it is registered successfully. But let's stop Wireshark and let's have a look at the registration process. I'm just going to stop Wireshark here, and then I am going to apply a filter. We are going to apply a filter because we want to look at the registration. We are going to apply this filter. SIP.ccq method is equal to register. We are going to say SIP dot and then it's going to show us the options that we have here. Once I just type SIP here, if I just type SIP dot, it's going to list all the possible filters that I can put that follow SIP dot. It's going to list them here. So let's have a look at what options we have. So if I just come here and I say SIP dot, and the command that we want to use, the filter is SIP.ccq method, but we are not looking for invite, we are looking for register. And then I'm going to press enter, and it has filtered all those packet captures. They've all been reduced to these 4 lines, 1, 2, 3, 4 lines, and our registration is here. So it send a registration request. So 192.168.1.55 is the micro SIP, and 192.168.1.2 is the MiVoice Business. This is where my micro SIP is going to come and register on this MiVoice Business. So we've got this. It sent a registration request to MiVoice Business, and MiVoice Business responded with a 401 unauthorized, and then it attempted to send a registration again, and this time around it was successful because MiVoice Business responded with a OK. Let us look at why this. So if we come down here, we are just interested in seeing the unauthorized here. Okay, or we can just start by looking at the details for the registration request. We are going to come here into the SIP register, and then there's this small arrow here. We are going to click on it to expand. We click on it to expand. Request line register, we click on it to expand. Method register, request URI. Then we click on message register to expand. We click on via SIP to expand. Okay, just bear with me for a second. Okay, let's look at it in another way. Let's remove the filter. Let's go to telephony, VoIP calls. Let's look at SIP. Okay, so let's recap. Micro SIP as the source and MIVB as the destination. We have the micro SIP sending a registrar request, and we got the MiVoice Business sending a 401 unauthorized. And then micro SIP send a second register request. This is the second one, which was successful because you can see MiVoice Business sent a 200. Okay, so let us just deep dive and see, and let us try and understand why the first registration request was not successful. we are going to highlight it, and I'm going to right click, and then I'm going to go click on follow and UDP stream. So it's going to show us packet by packet. Like this one, the register is the one in red. So whatever is in red here, red is equal to microsip as the source, and whatever is in blue is equal to MiVoice Business as the destination. So we have seen that in the register request, when we look at the register request, we can see that it is missing because to register we need a username and we need a password, which is encrypted. In these messages it will be encrypted as a nonce. This is beyond the scope of this tutorial, but you can go and research on nonce. So because this information is missing in this register request, so when microsip send this registration to MiVoice Business saw that there was no username and there was no password. So it rejected the registration. It rejected the registration by sending a registration failed, unauthorized, by sending 401 unauthorized. And then it says www authenticate the digest real RAM is equal to lab nonce this, and then after that microsip then send the registration request again for the second time. It sent the registration request again for the second time. This time it made sure to include the username. It said my username is 2002, and it included the rel, which is called lab, and then it included the password, which is encrypted here. Then when MiVoice Business received that, it compared the username if it was correct and the name and the password, and of course they were found to be correct, and then it sent a 200 OK, and then this microsip got registered and it came up. So this is why microsip is saying online here at the bottom right corner. So we discard this registration trace. So we are going to discuss this we are going to discard this registration trace, and then we are going to do an invite trace, packet capture or trace. where micro SIP is going to make a call to an extension on my voice business, which is extension 2001, and micro SIP is extension 2002. So we are going to send an invite by calling 2001 from micro SIP, and then we will take a packet capture and we look at it. So we are going to do that by, we clear that, we say we stop, we start the capture again, we continue without saving because we are discarding. I come here, I make a call to 001 and I call, and we answer it on the other side. Hello, hello, and we hang it up and we stop the trace, and then we filter by SIP. Let's just say SIP dot invite. We use this, we enter it. Dot method is equal to invite. We put in this filter, SIP dot csip dot method is equal to invite, and we press enter. So this is our output. You can see this is the invite, and if we, this is the invite, and we can look at the bottom here, we can see the invite. It sent an invite for 2001.8192.2001 8192.168.1.2. This is 2 in the 2 invite. So there's a way we can actually have a proper look at the invite by also right clicking on here and follow UDP stream. And you can see the invite, it came from 2002, and it was going to 2001 at 192.168. Okay, let me just use blue pen here so that there's a contrast. From 2002 at 192.1.2.168, which is just the MiVoice Business IP address, and to 2001 at 192.168. So it's calling 2001, and we got here SDP. It's sending an invite with an SDP, and this SDP is saying, oh, it means this is it's originating from 192.168.1.55, which is the micro SIP IP address. And it is M audio. It means it is using RTP port 4000. And C, it is the IP address of the micro SIP again. And it is sending us codec, the codec options that it has, which is G711, G711 A-Low, and G711 U-Low, which is PCMA and PCMU. And MiVoice Business responded to micro SIP with trying. Okay, let's have a look at this in a better looking way. Let me try this. We go to invite, we say follow SIP call. It takes us to the same place, but we are going to say telephony here at the top, and I'm going to say VoIP call, and it's going to give us this call, which is saying initial speaker. Initial speaker is the one who started this packet, which is 192.165, and it is from 2002 to 2001, and it's an invite. So we highlight it to see what's happening inside. Then we go to flow sequence. We click on flow sequence, and we are going to see this is the invite, and then there was trying, and then there was unauthorized, and then it acknowledged, and then it sent the invite again, and then this time, okay, this is micro SIP side, this is MIVB side. So the first invite got a trying, and it was followed by 401 unauthorized. Then the invite was sent for the second time, and then there was the MiVoice Business responded to the trying, and then ringing, and then the micro SIP acknowledged, and then there was an OK, and then there was an SDP from MiVoice Business, and then there was an acknowledge. At this time there was a conversation at this point here. There is RTP going on, followed by a bye and an OK. So let us now try and see why there was this unauthorized for the first invite. We highlight it, and we come to the bottom here, and this is the packet. We are going to say follow the UDP stream, so here MiVoice Business is sending not authorized, and it is saying here again, like what we saw in the request to register, the invite was missing, the authentication. As you can see in the invite here from MicroSip, we are missing authentication details. Which is what led to the 401 unauthorized. So to fix this, MicroSip has to resend the invite. Including authentication details. Let's see if it did that. So indeed, it then included authentication details here. Once it did that, MiVoice Business then replied with trying and then ringing, and then the call got connected. So we are now looking at this, the second invite, which was successful. So the second invite was responded to by MiVoice Business. First it sent trying, then it sent ringing, then MicroSip sent a P acknowledgement, and MiVoice Business sent an OK, followed by an SDP. Remember here, MicroSip sent SDP saying let's talk using this codec G711A or G711ULO. So here MiVoice Business is now confirming that let's use G711A low in its DP, in its OK to the invite SDP. And MicroSip acknowledged that yes, I'm acknowledged that we can talk on a G711A low. And at this point now, the conversation started. At this point, there were RTP packets now, until the person on this end sent a buy, and MicroSip acknowledged with an OK, and this was the tear down. Okay, so at this point, this is audio, this is your audio, back and forth. This is audio from MicroSip going in this direction. This is audio from MIVB. And then there's a buy, and then there's OK. So we can actually listen to what came from the MicroSip side by highlighting it, and we play stream. So this is the IP address of microSIP, extension 2002. It is using this port 4004, and this is the IP address of extension 2001, and it was using this port 50092. So we had audio through this. This is our RTP, and this is what we are listening to here. We can also listen to what came from the other end. We do this and we play. As you can see again, this is the IP address of extension 2001, and this is the port number, and this is the IP address and port number of microSIP, which is extension 2002, and this is our RTP, which is this. So let us close this and go one step back. Let's go back one step. By closing this, and we are here, we highlight here, and we say play streams. When we do this, we have combined the conversation. This is from microSIP, and this is from 2001. This is microSIP 2002, and the IP addresses are there. It's 192.168.1.55, port 4004. Is 192.168.1.56, port 50092. This is the information. These are the port numbers, and these are the IP addresses. So we can choose which one we want to play by highlighting it, and we click on play. Or we can highlight this and we click on stop play. So we have packet captured. We have captured a packet for registration, and we had a look at the packets. And number 2, we looked at the invite, and we looked at RTP, which was the audio, up until the call ended. And we have used this filter. You saw us use this filter, and we used also the invite. We also used this CSIP register, and we also looked at RTP. But this is combination of different commands. You are using two commands, two filters in one. Okay, for example, we can come to here. You can go to our Wireshark. We can close here. We can, there's no filter. We can say udp.rtp equals 5060. udp.port, sorry about that, udp.port is going to give us whatever was communicated via port 5060, which is the signaling. Let's look at another test RTP. It is giving us RTP packets. If we just say RTP, it gives us RTP packets. This is okay. Let's look at what else we can do here. Okay, here we can have a look at common SIP issues. We've got registration fails, where we saw a 401 unauthorized, and we saw what that meant. It is either the username was not provided, or the username was wrong, or the password was not provided, or the password was wrong, or the realm was not provided, or the realm was provided but being wrong. And we also looked at the nonce. So that or if we have one-way audio or no sound on one side, so it's an SDP mismatch, or it could be a NAT issue on the firewall. If it's an SDP mismatch, is the SDP is when in the invite, when we send an invite with an SDP and we say let's talk on maybe codec G711A, and the other side says let's talk on G711U, for example, and this is a mismatch. It can lead to no audio. Or we can have this one saying talk to me on this RTP port, and then this one ends up sending to RTP ports 50099 instead of 92. That's an SDP mismatch, but probably having code being caused by NAT as well. So that will lead to this, to no sound on one side. Then we've got call drops. Call ends after 30 seconds, or after a few seconds into the call just hangs up on its own. It is a timer issue, or an acknowledgement was not received in time. An acknowledgement got lost. Remember, when we look at the Wireshark, let's look at this. you can see there's this acknowledgement. If this acknowledgement which is coming this side, if it was not received, because it is acknowledging that yes, let's use G711, and if it was not received, then the call would drop. So let's just look at what else. Busy. When you call a number, you send an invite, and you get a 486 busy, user is busy or user is activated a do not disturb. If there is no ringtone, which is 180 ringing, and you don't hear 180 ringing, it means there's something wrong with the routing on your PBX or on your controller. Let us see what else we can do here. Okay, this is just an explanation of what I've been saying. If we get registration fails, of course there's also a 401 unauthorized. (403, 404, 408). Either we provided wrong credentials or we did not provide credentials at all, or it was unreachable. So if it is such that we provided wrong credentials, we look for 401 unauthorized in our packet capture, in our Wireshark. So if there's one-way audio, caller hears nothing, we suspect NAT or SDP mismatch, so we have to go and look at the SDP information. We are interested in looking at the C is equal to and M is equal to. So C will tell us who is originating and who gets the media. Of course, these will be IP addresses. Okay, let's have a look at that. Let's go to the Wireshark. Let's look at this SDP. Let's look at this SDP. I want to show you the C and the M. Let's look at it from here. Let's close this. Let's close that. Let's filter SIP. Let's look at this invite. Let's follow the UDP stream. And this is M. And this is the C. So it's telling us that we must send audio to 192.168.1.55, which is our C, and our M is go to 4004, which is the RTP port. So if the call fails and you get a 486 or a 503 service unavailable, destination busy or trunk is down, follow the SIP ladder. So what do we mean by the SIP ladder? This is what we mean by the SIP ladder. The flow sequence is what we call the SIP ladder. The flow sequence is equal to the SIP ladder. SIP ladder. Because if you look at this, it resembles a ladder. If this is a ladder, and this is the wall, and this is the ground. And this is our ladder. So when they say follow the ladder, they mean look at these steps and see which ones will be causing that failure. Call drops after X seconds. Look for a buy or a reinvite issue, and look for the buy or reason codes. Usually this is caused by the session timer having ended. If there was a session timer and the session timer clocks, maybe the session timer was for 3 minutes and the call has reached 3 minutes, which means it's going to drop at 3 minutes. So either we disable the session timer completely, or we make the session timer longer. If we don't get a ring back tone, invite sent but no 180 ringing has been received, and this 180 ringing probably is not being received because of the net issue, because of the file. So we've come to the end of our Wireshark tutorial. Hope it was eye-opening and you have learned something. If you have any questions, you can ask in the comment section. If we need to do a follow-up video on Wireshark, we can then arrange that. Thank you for watching and goodbye.